Hello everybody, welcome to Mastering Solutions. In this question, we have this figure here, and I know it looks a little wonky, but don't judge, you get the point. And so they ask, is it a single slit or a double slit? And we have to explain why. And so we know that this is a single slit pattern because we have a central bright maximum that has a lot more intensity than the other maxima. And it's also double the width than the other maxima. So that's how we know that this is a single slit. And then now that we know it's a single slit, we have to figure out what is the width of the slit spacing on this. And so to do that, we'll use the equation W is equal to 2 lambda L over A. Now A is what we're trying to solve for, right? Let's make a list. So A is what we need. We're told that L is 2.5 meters. Lambda is 600 nanometers times 10 to the negative 9 meters. And then we're not told in the question, but we can figure it out from our figure here that W, which is the width of the central bright maxima, is 2 centimeters. So we have 2 times 10 to the negative 2 meters. So now we need to rearrange our equation to solve for A. So we'll multiply both sides by A, and then we'll divide both sides by W. So A is equal to 2 lambda L over W. So when we plug this in, A is equal to 2 times lambda, which we said is 600 times 10 to the negative 9 meters, times L, we said is 2.5 meters. And then all of that gets divided by W, which is the width of the central max, and 2 centimeters. So now when we plug this in, we have 2 times 600 times 10 to the negative 9 times 2.5, and then all over, we said 2 centimeters, so 2 times 10 to the negative 2. All right, so that gives us 1, 2, 3. So 10 to the negative 3 is milli. So we have 0.15 times 10 to the negative 3 meters, or in other words, 0.15 millimeters as our answer for the width of the slit on our single slit.